Yes, class. Am I audible to all of you? Amna, Deborah, Mir Hussain, Sidra, Fadil. All right. So we had stopped at the Faraday's laws of induction. So two laws were there which you have to remember. The first law says that whenever there is a change in the flux, EMF will be induced. Increase or decrease in flux, EMF will always be induced. All right, and this EMF is directly proportional to rate of change of magnetic flux. All right, this is proportional to rate of change of magnetic flux. Now, there were some modifications which can come in your exam. So I just wanted to discuss that. See, you all know EMF is equal to current into resistance. All right. Current. Current is equal to EMF divided by the resistance. Right? Now, what is EMF? Let's separate this R. What is EMF? EMF is minus d phi over dt. Correct? EMF is minus d phi over dt. This is what? This is the induced EMF. So you can use this value also if current is asked. Suppose this is asked in terms of charge. This is asked in terms of charge. So you know current is dq over dt. So what you can do if current is dq over dt, so this is equal to current. And what is the value of current that we have just concluded? 1 by r d phi over dt. This dt cancels. So dq is ultimately equal to d phi over resistance. All right. And you can use, if a small variation is given, so for the charge, you can use change in flux by the resistance. This modification you can use. Let's practice one question. First, write it down. A 10 ohm resistance coil has 1000 turns and at a time 5.5 into 10 to the power minus 4 Weber of flux passes through it. So you have number of turns, resistance, initial flux. Then it says flux falls to this, means this is the final flux. In time is also given. Resistance, number of turns, change in flux. You can find out the charge and the voltage. See, what all things are given? Resistance is 10 ohm, number of turns 1000, initial flux 5.5 into 10 to the power minus 4 Weber, final flux 0.5 into 10 to the power minus 4 Webers. So first let us calculate the change in flux. First let us calculate the change in flux. Final minus initial. So this is 0.5 minus 5.5 into 10 to the power minus 4, which is equal to minus 5 into 10 to the power minus 4 Webers. Delta T is equal to 0.1 seconds. Now for voltage, voltage means EMF. EMF is d phi over d. Minus, what is flux? Flux is minus 5 into 10 to the power minus 4. Over dt, dt is 0.1 seconds. That becomes 5 into 10 to the power minus 3 volt. You have EMF. For charge I told you. For charge, you can use change in flux by the resistance. Change in flux is minus 5 into 10 to the power minus 4. Resistance is 10. So this is minus 5 into 10 to the power minus 5 coulomb. This is how you can use those formula and it will save your time before the derivation. Write it down. Write down the solution. One more question we'll see. Done. Now, see, this says that a coil of cross-sectional area A lies in a uniform magnetic field B with its plane perpendicular to the field. So in this position, normal to the coil makes an angle 0 degree. Normal to the coil means perpendicular to the coil, area vector which we use. So the coil rotates at a uniform rate to complete one rotation in time t. Average, you have to find the average induced EMF in the coil during the interval. So two intervals are given. One I'll tell you, other you'll be able to write it. First is 0 to 90 degrees. Second is 90 degree to 180 degrees. See, if I say I have divided all the angles, this is 0 degree, this is 90 degree, this is 180 degree, this is 270 degree, and here again we'll have 360 degree back. Now total is this angle, and I'll tell you for the entire 360 degree we are having the time t. So what would be the time just for 0 to 90 degrees? 0 to 90 degree is just this, which is if total is t, so 1/4 of it will be, time will be t by 4. That's the difference only that will be coming. See, initial flux, if you calculate BA cos 0 degree, fine, which is equal to BA. But secondly, it is saying normal to the coil makes an angle 0 degree. Fine, this is 0 degree. The first angle which is given to you here is 0 degree. Second angle that is given to you is 90 degree. So phi 2 is BA cos 90 degree. Cos 90 is 0. So this is 0. So write down, if you will write down the value of EMF, change in flux minus d phi over dt. Look, change in flux is minus, this becomes 0 minus BA divided by T by 4. So final value is 4BA by T. This 4 will go up. Similarly, second part is saying 90 degree to 180 degree. Look, for the second part also, if you have this, you should be able to write, this is 0 degree, 90 degree, this is 180 degree, this is 270 degree, this is 360 degree. Fine. Now it is saying 90 degree to 180 degrees. So from 90, if you will go to 180 degrees, see, entire was t, entire time duration, entire angle, that is 360 degree. 360 degree is the total angle of a circle also. It forms a complete circle. So 360 degree is t. So if you go from 90 degree to 180 degree, this is just quarter of a circle. So time duration here will also be t by 4. Suppose if it is 0 to 180 degree, then 2 quadrants, that will be half t by 2. Suppose 3 from 0 degree to 270 degree. So these 3 will be highlighted, that is 3t by 4. Like this, you have to decide the time. Now again, initial angle is given 90 degrees. So this will become BA cos 90 degree, which is 0. Second phi 2, this is BA cos 180 degree, which is minus BA. So we have all the information. Now EMF is minus d phi over dt. Minus, what is the final flux? Minus BA, initial minus 0. And this will be divided by t by 4. So same answer, this will be also there, 4BA by T. Here in these cases it is coming. Otherwise it can be different also. But you should know which angles to write, how to write. This angle is the initial angle, this is the final angle. And between them you will be having the time duration. Write down the solution. Is it clear to all of you? Fadil, it's clear? Sidra?
Yes, ma'am.
Have you understood how to write the time? Okay, if I ask you from 90 degree to 270 degree, what will be the time that you all will write? 90 degree to 270 degree. How many quadrants will be selected? How will you write? If it is from 90 degree, what will you write? Aliza, Amna, Deborah, Sidra, Fadil, what will be your answer if you've understood this question, how to write the time? If it was from 0 to 90 degree, it was 1/4 of the time. So if I'm asking if it is from 90 to 270 degree, how much will be the time that will be taken? Yes, Fadil? Answer? 2 by 4, which is half. Amna has already written half. Correct. Good. Half. See, this is 2 by 4th. No, 2 by 4th means half of the time duration. Fine. So like this, if you all are able to write this, otherwise you can see calculations. There weren't any calculations as such. Fine. Write it down. This completes with this first portion. Now we'll do Len's law then. Yes, now coming to Lenz's law. So see, E is equal to minus d phi over dt. So E is equal to just d phi over dt. This we studied, which was the Faraday's second law. But why were we having that negative sign? I told you that I'll discuss Lenz's law. So that significance of negative sign will only be given through Lenz's law. Now see, suppose this is a coil. Here I have, this is having some magnetic field lines. Let's say I've increased the magnetic field lines. All right. Increasing magnetic field lines will be having increasing flux. Now, when the flux increases, there is an induced EMF in the circuit and induced current. Now, Lenz's law will tell you the direction of them, especially the direction of induced current. So, negative sign signifies the fact that the direction of induced current is in such a manner that it should oppose the cause that it is producing it. See, what is the cause that is producing EMF or current? Change in flux. So if the flux is suppose increasing, the aim of the induced current will be to decrease the flux. If it is decreasing, aim of induced current will be to increase the flux. It will just oppose. That's why we have the negative sign. It is an opposite direction. It will oppose it. If it is increasing, it will try to decrease the flux. If the flux is increasing, it will try to decrease it. So this, because this is the cause of the EMF, induced EMF and induced current. So direction, when we talk about the direction of induced current will be in such a manner that it will try to fulfill its aim. And what is the aim? To oppose the cause, whether the cause is increasing or the cause is decreasing. So Lenz's law says that direction of induced current is such that it opposes the cause that produces it. And what is the cause that produces it? That is the change in flux. This is what is meant by Lenz's law. And Lenz's law is in accordance with the conservation of energy. This comes a lot where you have to define it is in conservation with energy or what. Fine. Suppose I'll give you an example. In this example, let's say this is a circular coil. I'll have a bar magnet over here, and this is North Pole and this is South Pole. So North Pole, I am bringing the magnet with, let's say, certain v velocity. I'm bringing the magnet near the circular coil. So what is, if the magnet is coming near the coil, so magnetic field lines will increase in the coil because magnet is coming near the vicinity of it. So what is the cause? Cause is this approaching North Pole. I am taking the end, that is the North Pole, which that should point towards the coil. So North Pole is pointing toward it. So cause is approaching North Pole. All right, the cause is approaching North Pole. So according to Lenz's law, the aim will be to repel the North Pole. Then only, by repulsion, the magnet will go and the magnetic field lines will decrease. This is the only possible way, right? So how can North Pole be repelled? Just one method is there, that if the coil develops north polarity, then only the bar magnet will be repelled. It will go behind, the magnetic field lines will decrease, flux will decrease because the flux was increasing, right? So if this happens, North Pole's direction, I have already told you, whenever there is North Pole in your magnet, direction of induced current is anti-clockwise. So have we not obtained the direction of induced current? This is anti-clockwise. This is how Lenz's law will be working. Suppose let's take one more example. This is a coil. This is a bar magnet. South pole I am bringing. So what is happening? Magnet is coming near the coil. Flux is increasing. Aim is to decrease the flux. To decrease the flux, magnet has to be repelled. And the only possible way is to develop south polarity so that it repels it. When south polarity is developed, I have told you a trick also to remember the direction by just drawing the alphabets, and like this, you can mark the arrows. So clockwise is the direction of the induced current. like this, and see, everything is opposite. This direction was in such a manner so that this could be achieved. What, that's why we have this negative sign also. One more example, let's take. Suppose this is saying coil is there, north pole is moving, this is, here we are having south pole. Fine. So north pole, let's say this is, instead of moving towards the coil, this is decreasing. This is moving away from the coil. In the above two cases, we discussed that the bar magnet was moving near the coil. In the first case, we had seen that north pole was approaching. In the second case, we had seen that the south pole was approaching. Now I'm saying the bar magnet is moving away from the coil. So what is happening to the magnetic field lines? Magnetic field lines are decreasing because bar magnet is moving away. Magnetic field lines are decreasing means magnetic flux is decreasing. So if magnetic flux decreases, the aim will be to increase the flux. Correct? This will be our aim. So how can north pole be, if north, because the cause is moving north pole. So what is one method by which the magnet can come closer to the coil and magnetic field lines will increase and so the flux? The only method is that if south polarity develops, south polarity will attract north polarity. So see, this is south polarity. So this time the direction of coil will be clockwise despite the north pole being near the edges of the coil. So here the direction of induced current or induced EMF will be clockwise. One last example. If the coil is moving, if the bar magnet is moving with south polarity. So same thing, north pole will be developed to attract it, anti-clockwise will be the direction. Write down the entire Lenz's law. Whichever point is not clarified, let me know. This part is very important because you will be getting random figures to describe. Write it down. See, class, these are the two cases that I'll just discuss with you because this is given in NCERT in the form of question. So I'll discuss it with you. Direction of induced magnetic field. So suppose this is a coil. Coil is coming out. So if coil is coming out, number of lines are decreasing. Correct or not? Number of field lines are decreasing because it is leaving the magnetic area. So if magnetic field is decreasing, your flux will be decreasing. So the aim will be to increase. Right? What is the direction of original? These are the original magnetic field lines. These are the original which are present. We'll try to find that direction of magnetic field for which the direction will be opposite or same. See, if I say both the magnetic field lines, original and induced, if they are in the same direction, B naught plus Bi will lead to increase in magnetic field. Original is also in pointing towards one direction. Induced is also pointing towards one direction. Net magnetic field line will increase. Suppose one is taken B naught, one is taken in opposite direction. Then it would be B naught minus Bi, which is magnetic field lines are decreasing. Correct? Magnetic field lines are decreasing. So which one of the case you have to follow, that depends upon the condition which is given. Suppose here magnetic field is decreasing. So we will use this because we have to increase the magnetic field. Direction of induced current will be in such a manner to increase it. So if we have to increase it, we have to have both of them in the same direction. What is the direction of original one? Inwards. So induced magnetic field will also be inwards. Now put your thumb inwards, right hand thumb inwards. What is the curvature of finger if you put your right thumb inwards? Clockwise or anti-clockwise? Quickly answer. If you are placing your thumb inwards, because see, original magnetic field is inwards, induced also, if it becomes inwards, net will increase, and that is what we want, and that is the only way to oppose. If you put thumb into the screen, what is the curvature of your fingers? What is the curvature of your fingers? Clockwise or anti-clockwise? Check answer. See, if you put your thumb inwards, your thumb will be staying here, fingers will be moving like this, which is clockwise. Like this, you have to answer. This is what is written. Induced current will try to increase flux. Direction of induced current is in such a way to increase the magnetic field. This is how you have to consider. This is the first case. Suppose I'm saying this is a coil and this is moving into it. So what is happening? This is the coil and this is moving into this. If this is moving inwards, then what is happening? Magnetic field lines will increase, flux will increase. So which case we'll follow? Second one. Why? Because our aim now becomes to decrease the magnetic field, not our aim, induced current aim. So how to decrease the current? By taking the opposite direction of magnetic field lines. Original is pointing inwards. So outwards will be the induced one. If you keep your thumb outwards, curvature of fingers will be anti-clockwise. So in the second case, you will get the direction of induced current is anti-clockwise. First, tell me, these 2 points you have understood or not, because these are given separately in your NCERT. They can be asked to you. Let me know you've understood or not. Yes, Aliza. Fadil, understood?
Yes, ma'am.
Amna, Fadil, they have understood. Sidra, what about you? Deborah, clear? Good. And Aliza, you're not answering. Aliza and Sidra, I hope this topic is clear. Lens law.
Yes, ma'am.
Okay, let me know if you people need help. Write it down. Now, from this, motional EMF is left and induction is left. That we'll complete tomorrow. You all can start leaving. No assessment for today.